Okay. Now derivative is always, remember, rate of change. Correct? When you're finding derivative of any function, you're finding the rate of change of that function. So if you have a curve, you're finding the slope of the tangent to the curve. That's what you need to remember. So derivative is always rate of change. Now the first thing is derivative of x raised to n is nx n raised to n minus 1. Now what is important in this rule is your x should always be in the numerator. So that means if your y is equal to 1 over x cube, if they ask you to find a derivative, what should you do? First you take your x in the numerator and then you find a derivative nx n minus 1. Yeah. So nx minus 3 is x. Nx n minus 1. So then subsequently you can write like this if you want to. But remember that it should always be in the numerator. Yeah. Okay, that's one thing you need to remember. Now, as I'm doing this, I remember. Okay, okay, we'll come to that. Root, you know how to work with roots? Yeah, 1 over root 2x. Yes. So suppose if I have root x, 1 over root x, what will the derivative be? So y is equal to x raised to minus half. So dy by dx will be minus half x raised to minus half minus 1. Yeah. So minus half x raised to minus 3 by 2. Yeah, like that. Yeah. Derivative of sin x is cos x. Yeah. Derivative of cos x is minus sin x. Yeah. This is the only formula. Derivative of e raised to x is e raised to x. Derivative of ln x. Now this is your chain rule. Yeah. If you have your composite function, y is a composite function of y is equal to gu and u is a function of x. So if I want to write this, your chain rule like this in one form. So y is equal to g of f of x. Correct? Then what will your dy by dx be? Take the derivative of the outer function. F dash of x. No, take the outer function first. Take the derivative of the outer function, multiply by the derivative of the inner function. The formula booklet they have given like this. Yeah. But for all practical purposes, if you remember like this, it will be always be better. Yeah. For all practical purposes, remember, you know, sometimes they give you the table to work with. Yeah. So that time this will be useful. Which one is why you do 1 upon f dash of x into isn't there one? Chain rule. Yeah. ln x. ln x is 1 over x. And then if there's a chain rule into that. Yeah. So basically what's going to happen is all these have their cousins. Yeah. So if your fx is equal to sine fx, sine function, if your y, let me call it y, is equal to sine of some function of x. Yeah. Then what will the derivative be? Minus cos of that one. Derivative would be minus, plus, no? This is derivative, not integration. Cos of fx. Yeah, cos of that. Into the derivative into f dash x. Yeah. So similarly, e raised to fx, what is that derivative of e raised to fx be? E raised to x into f dash. E raised to fx. Yeah, e raised to fx into f dash. Into f dash x. Yeah. So if you have ln fx, what will the derivative be? 1 upon f fx. Into f dash. Yeah. That's your y dash. That's your y dash. You give like some sine cos. Sine cos we did. Chain rule. Here we did not sine cos chain rule. Yeah. Sine fx is equal to cos fx into f dash x. Yeah. Huh? Yeah. That's your chain rule for sine and cos. Ditto. Yeah. Product rule u into v. Yeah. U into derivative of v plus v into derivative of u. Yeah. So uv dash plus vu dash. Plus vu dash. If you vu square minus uv square upon v square. Vu dash minus uv dash upon v square. V square. Yeah. Upon v square. Yeah. Okay. Yeah. Kinematics. Acceleration is rate of change of velocity. Yeah. And this is second order derivative of displacement. Remember, s is displacement. Yeah. So if you have your s, velocity, acceleration. Yeah. And then you differentiate. Distance. Yeah. No. Distance is not there. You integrate. If you integrate acceleration, you'll get velocity. But if you integrate displacement, won't you get nothing? You get a 0. Then distance is just mod
Oh, this
this is mod of velocity.
Mod of velocity.
Integral of, they were coming to that. You know this distance is integral of mod of velocity function.
Yeah.
With t1 to t2.
Yeah.
Now this you have to do on calculator. For SL, this is you have to just use GDC. You don't have to do mod by hand.
Yeah.
Okay. Displacement is you integrated. Correct with this.
Velocity, because accelerate velocity.
Now the discussions. Now I'm carrying on the discussions from your guide. Now SL 5.1 you don't have to do anything. You have to simply remember the different notations and all. Limits you don't have to worry at all. Yeah. SL2, this is important. Decreasing and increasing function. Yeah. So decreasing and increasing function, your function is increasing when your first order derivative is greater than 0. Yeah. And it's decreasing when your first order derivative is less than 0. Yeah. Now generally we use sign diagram to do this. So we draw a number line, we mark the roots on the number line. Yeah. And you put in the values and you get a sign.
But you sub it into the original function.
No, you sub it in the derivative.
You sub in the derivative function.
You sub in the derivative function.
So say roots are 1 and 2. You sub in say 0 and 3.
Correct. So if you so basically you did your f dash x is equal to 0. You solved it. Yeah. You got 1 and 2. Let's say. Yeah. Then in the expression of this you put f dash 0, f dash 1.5. Yeah. Correct?
And f dash 3.
And f dash 3. Like you take one. And then if you get this is positive, this is negative, this is positive, suppose. You just look at the sign. Yeah. Yeah. So positive, negative, positive. Yeah. So wherever it's positive, the function is increasing. Yeah. When negative is decreasing, when it's positive is increasing.
Yeah. It's decreasing till it's less than 1.
Yeah, it's increasing. So
increasing when it's less than 1.
So increasing, when is it increasing? When x is less than 1 or when x is greater than 2. Yeah. And it's decreasing
and
between 1 and 2 it's decreasing. Yeah. Okay, so this is what we do. So graphical interpretation. So f dash x is greater than 0 means it's increasing. If f dash is equal to 0,
it's stationary.
Stationary. And less than 0,
decreasing.
Okay. Derivative of fx, we did that in the last formula from the formula book. Yeah. Derivative of the functions of the form, if you have sum, you take each of them separately.
Yeah.
You know that. Yeah. Tangents are normal at a given point and the equations. So what you need to do is to finding the equation of the tangent. If you're finding, so they'll give you a function. So they'll give you, let's say x value is a, and then give you a function. And they say find the equation of the tangent. Correct? They'll give you some numbers. So what is the first step you'll do? You'll find out the derivative, f dash x. Yeah. It can be chain rule, it can be product rule, it can be quotient rule. Use the rules of derivative to find f dash x. Yeah. The slope of the tangent
will be f dash of a.
Slope of the tangent will be f dash of a. Means you put that question, that value of x in the derivative, that will be f dash a. Your y coordinate will be fa. So if you put a in the original function, you will get the y coordinate. Yeah. If you put a in the derivative, you will get the slope of the tangent. Yeah. So it depends where you substitute a.
So y coordinate.
Y coordinate, yes. So then your equation will be y minus y1. Yeah. That's your y1. Yeah. Is equal to m. M is the slope of the tangent. X minus x1. Yeah. That's how you find.
But x1 will give you the.
They will have to give you. Otherwise you can't do. Otherwise you can't do it. No? You can't do anything about it. Now similarly, suppose they give you some value of x. They give you fx, and they want the equation of normal.
So you find it and then you reverse the slope.
Negative reciprocal. So first step, you will find your f dash x. Yeah. Second step, the slope of tangent will be f dash a. Yeah. Correct? Means you substitute this in slope of the normal.
So we 1 over minus f dash a.
Negative reciprocal. Yeah. And the equation would be, acha, you have to find y. Y is equal to fa. Put the value of x in there. And then your derivative, your equation will be y minus y1 is equal to m. M is your slope of the normal that you got. Minus 1 upon f dash a into x minus x1. So that's how you find out tangents and normal equations. Okay. Now I'm doing all the derivatives first. So integration can make a separate video for that.
Yeah.
This also we did sin x, cos x, e raised to x, ln x.
Yeah.
Multiples of this function and all we did, product rule and all, composition we did, product rule, quotient will be discussed in this video.
Derivative of ln x is 1 over x.
Yes, that's the linear formula. Second derivative. Second derivative, both the notation you need to know. D square y by dx square is also the notation for second derivative.
Yeah.
This means second derivative. Means what you do is, whatever derivative you get, you derive that again. You differentiate that again. F double dash x is your second order derivative. Graphical behavior of functions, including relation between f dash and f double dash x. Now, this is a bone of contention. That is sometimes, people don't understand this. We'll come to this, but before that, let's do this and then we'll come to that. Local maximum, local minimum.
Yeah.
Local maximum. How do you find a local maximum?
F dash of x is equal to 0.
Very good. So to find local maximum, you first step, you take f dash x and then you solve f dash x equal to 0.
Now how do you know it's a maximum?
How do you know? So you suppose you get two answers. For simplicity, you get two answers. Now what you do in your third step is you draw a number line. Mark this a and b on the number line. Put the test values.
So it's minus to plus, then it's
minus, plus, minus, suppose you get. Now if it's minus to plus, now remember minus means this is decreasing. Plus means it's increasing.
Yeah.
So that means the minimum.
Yeah.
So if it goes from minus to plus, it's a minimum. So there's a minimum at x is equal to.
Yeah. And there's a maximum.
Maximum is it's increasing and then decreasing.
Yeah.
So that's the maximum.
But
the maximum value. The maximum value is you find a y value. You put this back in the original function. You'll get the y value. That's your maximum minimum value.
But is there another way to find out the maximum?
Yes, your second order derivative, sine of the second order derivative. If your second order derivative is positive, then it's a minimum.
So you find f double dash of x and then substitute the
Correct.
a and b.
Yeah. So
if it's greater than 0, then it's a minimum.
Like in this sum only. So you got a value of a and b.
Yeah.
So you do one more step, you find a second order derivative of the function.
Yeah.
And then you put your a in that.
Yeah. And
if your a will come, let's say positive.
Yeah.
Means it's concave up.
Then it's a minimum.
Yeah, then it's a minimum.
Yeah.
It also means it's concave up and therefore it's a minimum. And if your f double dash a is negative, it's concave down and it's a maximum.
Yeah.
Okay, so this is important to remember. Optimization, including profit, area and volume. You have to know all the formulas and you have to revise all the sums on optimization.
Yeah.
We have to frame equations. And in IB they'll give you leading steps.
Yeah.
So find expression.
Sometimes they'll give you the equation.
They'll give you the equation. So if you don't get the equation, you start working with the equation.
Yeah.
So don't get stressed about it. Yeah. Because in textbook they don't give you that equation, so you get stressed how to frame it.
Yeah.
Point of inflection with zero and non-zero gradient. First of all, you need to understand what is the point of inflection.
The point where it goes decreasing.
No, where the curvature changes. The points where the curvature changes.
Yeah. So increasing and decreasing.
No, it's increasing and increasing.
Huh? How is it? Yeah. Okay.
It's increasing, increasing.
Yeah. Okay. Fine.
Decreasing, decreasing. That's your point of inflection. But it's a point where the curvature changes. So this is your concave down and this is concave up.
Yeah.
That's your curvature. Yeah. You can have like this also. So this is a point of inflection somewhere here. This is a point of inflection here. So see, this is concave down, this is concave up. It's concave up, then concave down. Now, this is your point of inflection with zero gradient. This is a point of inflection with zero gradient.
So the horizontal point.
The horizontal point of inflection.
Yeah.
This is the non-zero gradient. So if you have a horizontal point of inflection, your second order derivative is 0. Remember there are two things you need to do. There's a sign change. Two things are there. for point of inflection. There should be a sign change and second order derivative 0. Remember, it's given over here clearly. F double dash x is not a sufficient condition.
But you said for the first term, there is no sign change.
There is a sign change. There is a sign change. It's concave down and concave up now.
Yeah.
There is no sign change for the first order derivative.
Yeah.
There is a sign change for the second order derivative. The concavity is changing.
Yeah.
So remember, it's clearly mentioned.
Sign change the graph, the curve.
For the derivative, there's a sign change.
Yeah.
For the second order derivative, there's a sign change. So if it was sign diagram for the second order derivative, this is negative, this will be negative, and this will be positive here. So this would be negative, and this would be positive. So concave down and concave up for second order derivative. First order derivative is going up and up only.
Yeah.
So be careful of that.
Yeah.
So both are there, and IB, this is very important. They ask number of times. This is very, very important. Both the conditions are there.
Sign change.
Yeah. Sufficient is not, this is not sufficient. Necessary and sufficient conditions, both. So this is necessary and this is sufficient.
Yeah.
Use the terms concave up for the second order derivative being positive and concave down for second order derivative being negative.
Yeah.
Okay. Kinematics we did. Correct. Integral we will do the next video. Now I'm going back to this now. Graphical behavior. How to graph from a function, how to graph the derivative.
It's a lot smarter.
Yeah. This is slightly tough. So now what you need to do is
They don't ask you that much, no?
They ask mostly in HL and SL they don't ask because they are slightly kind to you. But that doesn't mean that kindness will continue every year.
Yeah, fair.
Now, what you need to do is when you see a graph of fx, you make a table like this. You first look at the graph of fx, mark the local maximum, mark the local minimum, mark the point of inflection, mark the horizontal point of inflection. Horizontal, I am calling it POI for short, but you cannot do that.
Yeah.
Only if you are above 18, you can write POI, point of inflection. Are you below 18 or above 18?
Below.
So you can't use POI. Correct? Horizontal point of inflection, non-horizontal point of inflection. So you mark that first thing.
Yeah.
Correct? Now for the graph of f dash x, wherever there is a local maximum, that will be the 0.
And even for minimum.
Even wherever is the local maximum, that will be the 0. Then that will become the x-intercept.
Yeah, both.
And vice versa. Suppose if they give you a derivative graph, then 0 can be local max.
And 0 can be local min.
But there is one difference between these two. Your local max will go from, now local max ka sign diagram is what? If you do the first order, so local max will go from negative to positive. Local max, so local max is negative to positive. You see that earlier we had drawn that somewhere. Local max, the derivative is negative, positive to negative.
Yeah, positive negative.
Because if you have local max, your derivative here is local max I'm talking of. No? Yeah. So positive to negative. So this will be positive, it will go to negative. It will cut like this. Local min would be negative to positive. So you always interpret from left to right.
Yeah.
So this is how the graph will cut. Horizontal point of inflection will be the turning point for the graph. And it will touch the x-axis. It will be the turning point for the graph. It will touch the x-axis. I'll show you an example. Don't worry. And what is the non-horizontal point of inflection?
So what's the difference between horizontal and non-horizontal?
These are your horizontal points of inflection. And these are your non-horizontal.
So when the slope is 0.
When the slope is 0, it's horizontal point of inflection. And these are non-horizontal point of inflection.
So then you have to specify, right?
You have to see it, you have to observe it. If you see like this.
So like when they say find the point of inflection, you have to specify.
Unless specified, unless they ask you specify.
But then how do you know? Like after
How do you know?
find it?
You find it, then you put that answer in the first order derivative. When you put the answer in the first order derivative, then you can come to know whether it's horizontal or non-horizontal. So if it's a horizontal, so basically if it's a horizontal point of inflection, for a horizontal point of inflection, your second order derivative will be 0, plus there will be a sign change for the second order derivative, plus your first order derivative will be 0 at that point. Okay, for your non-horizontal point of inflection, your second order derivative will be 0. You'll solve this, you'll get, let's say, value of x is b after solving this. I'm assuming b is non-horizontal. Sign change has to be there across b. And when you put the b in the first order derivative, it won't be 0. Right?
So that's when you have a horizontal.
Yeah. So horizontal point of inflection for the derivative, it will touch the x-axis. Turning point plus does not touch the x-axis. Does not touch the x-axis. Now let me give you an example for this. So I'll give you one with, let's say, like a cubic function. This is given to you. This is your x-axis. This is your y-axis. Or let me, okay, yeah, okay, let's do this. So what will this be? Now what you need to do is think in terms of the slope of the tangent. You have to sketch fx. Sketch, this is given, sketch, the question is sketch f dash x, looking at the graph. So check, does this graph have a local maximum?
No, it doesn't.
Doesn't have. Does it have a local minimum?
Yeah.
No, none of them, no?
It has, it touches the x-axis.
No, local minimum is, see, when you have like this, no? This is your local max.
Oh, okay.
This is your local minimum.
No, it has a non-horizontal.
Does it have a point of inflection? Yes, it is having this.
But it's non-horizontal.
Non-horizontal.
Yeah.
Now, if it's non-horizontal point of inflection, what is going to happen? There will be a turning point and it will touch the x-axis.
Yeah.
So what is going to happen is when you're drawing this, you think of the slope. So think of the tangent. If you draw tangent here, will the slope be positive or negative?
Negative. No, positive.
Positive. Then here, positive. Here, 0.
Yeah.
So what is going to happen over here? The slope is positive and decreasing. It will become 0. So at point of inflection, this will be the turning point. It will touch the x-axis. Okay. Now let's say this was the horizontal. Now let's say suppose you have a graph like this. Correct? And okay, like this. Let's take it individually. Suppose you have a graph from here to here. The question is, they've given you without paper 1, sketch f dash x. Step 1. Identify. So
there's a local
max. So there's a max at A, let's say.
Yeah. There's a
minimum at B.
Yeah.
And point of inflection at
non-horizontal point.
C. And it's a non-horizontal.
Yeah.
Non-horizontal point of inflection. Now what will you do for your derivative?
So the slope.
See, now what will you do? You will draw the x-axis, y-axis.
Yeah. The slope is
now first part is wherever the max and min is there, that will become the intercept. That will become the intercept.
Yeah. Also, you know it's like a cubic graph, so it has to be a pattern.
No, but they'll give you a random thing. Right now, yeah, right. They'll give you a random thing. Now see, now you think here, what is happening to the slope? You think of the slope.
It's increasing, positive.
Slope is positive. First you think it's positive.
Yeah.
Positive, and it's becoming 0.
Yeah.
So it's positive and becoming 0. So it's positive and becoming 0. Correct?
Yeah.
Then the slope is negative. Here the slope is negative, and then after that it will become positive. So that means this will go like this, and then so yet at C that's a turning point.
Yeah.
But this is not touching the x-axis. Here it was touching the x-axis.
Yeah. Otherwise
here if you draw a tangent, the slope of the tangent will be negative. Therefore, this is negative. So this is your f dash x. Here your f dash x is positive. Here your f dash x is negative. Yeah. So this is your A, B, and your C. Your point of inflection becomes the turning point. Yeah. Just remember that.